We are doing quadratic equations today. Quadratic just means that there's going to be something squared in it. I highly encourage, and I know a lot of us aren't going to pay attention or we're not going to remember this. I highly encourage you decide how many terms there's going to be. In this one, I have 3 individual terms, not counting 0. For number 2, I have 2 terms. If I look at number 4, 5, and 6, those will all have 2 terms. 2 terms, because on this one, when I subtract 11 over here, I will have 2 terms. I highly encourage you know that, because unless you have 3 terms, none of the special things apply. Yeah?
Wait, so wouldn't this be 2 terms then too once you put the 30 on that side?
This would still be 3 terms. It'd be 3 individual numbers. It's 3 things that I can't put together. Okay? You could look at it as being 4 because you have that 0, but I don't count the 0. If you have 3 terms, you have to either factor, turn it into a binomial times a binomial, you can complete the square, or you can plug it in the quadratic formula. If it has 2 or less terms, there's usually a much easier way to do it. So keep track of that. Keep track of how many terms you're going to have. It will dictate what you need to do. So we notice that this one has 3 terms, which means you either need to factor it, complete the square, or put it in the quadratic formula. All 3 will get you the same answer. I am going to factor this one. I'm going to turn it into a binomial times a binomial. Yeah? Okay. Well, you can give me the answer when it gets there. I do also want to point out, this is an offshoot of a lesson we've already done. We've already done factoring in an earlier lesson. The only difference was this. This was what was on that quiz. This is not an exact question, but I said factor it. I'm going to factor it into a binomial times binomial. The only thing I'm adding today is that 0, which means I can now solve it. I can factor it and use that factorization to solve the problem. So I highly encourage we start being able to find a way to guess and check through some of these. Notice there's a 1 in front of this y squared. This is a perfect example of guessing and check. It will save you time and it'll save you space. So whenever there's just a y, an x, whatever, just squared all by itself, you know for a fact that it needs to be y times y out front. This is what I mean guess and check, because it has to be a y and it has to be a y. Compare that to if this isn't the, let's say I have 6x squared plus 3x plus 2 equals 0. Probably not a good time. Don't write that down. I'm just hypothesizing. This could be 6x times 1x. This could be 3x times 2x. It could be flip of those. It just creates too many scenarios. Some people can guess there and check their way through it, but sometimes it creates too many situations that you're just sitting there on that one problem trying to guess and check your way through it. Bless you. So I typically just use guess and check if this is a 1 in front of your square. So it's a 1 in front of the square, so I know it's y and y. Now all I have to do, it's kind of like that AC air conditioning in Beyonce, except I can do it all in one step. I'm just looking for 2 numbers that multiply together to give me 30, but add to give me negative 13. And like I said, it's kind of guess and check, where I might go, you know what? 2, let's go, maybe I 6 and 5. Is there any way to use a 6 and a 5 to create a 13? No. Okay. What else could we use? Maybe a 15 and a 2. Is there a way to turn 15 and 2? Well, we know 15 times 2 is 30. Is there a way to add them together to get a negative 13? Negative 15 and a positive 2. I'm going to give you one that looks close. That one is the right one, but I'm going to give you one that's close. Why doesn't 3 and 10 work? 3 plus 10 is 13.
Negatives is a positive.
Because they both have to be, the only way for this to work, they'd both have to be negative, which would make that a positive 30. So the only one that is going to work, and there's always just one that works, is going to be a negative 15 and a positive 2. Now, on the quiz we just took, this would have been your answer without the 0. But we have to go one step further. We have to realize that this is something times something equals 0. You have something called the zero product property. The zero product property says if you have a chain of things being multiplied, if it equals 0, at least one of those things has to be 0. I doubt you guys did this, but we were nerdy as kids where we'd always go up to like adults and be like, what's 15 million times 3,000 times 0 times 15?
0.
It'd be 0 and be like the smartest kids in the room. One of those things is 0, all of it's 0. So what we really have is we have two equations built in here. Either that y minus 15 equals 0, or that y plus 2 equals 0, or both of them equal 0. In order for y minus 15 to equal 0, y would have to be 15. That is just solving that equation or understanding that a 15 would make the 0. A negative 2 would make this 0, so we'd have y equals negative 2. Whoop, that's a negative 1. That's a negative 2. That makes a lot more sense. All right, for our next one, I'm going to notice there's not 3 terms. There's not 3 terms. I'm still going to factor it, but I'm not going to factor it this way. I'm not going to turn it into a binomial times binomial. There's not a lot of work you have to do.
You can do these with parentheses, right? Not brackets.
I think you're talking about, could you do this as your answer? Negative 2. It'd still be a brace.
Do you have to do that?
You don't have to do that. You don't. Yes?
So do you have to plug in both the variables to see which one works, or you just leave it like that?
They both work. This isn't geometry. In geometry, you'd had to plug them in because you couldn't get negative answers out. So like you're finding like a side of a right triangle, and you were like, we can't have a negative side, so you have to plug it in to see if it comes out to a negative or something. You can't have negative answers. In this class, we're good. We're good with those. We're not dividing by anything, so there's really going to be no extraneous solutions. When you start dividing, when we start doing rationals, you will have ones that don't work for answers. All right, for my next one, I'm going to notice there's not 3 terms. But I'm going to notice that all of the terms have W in them. Our goal is always to put like terms together, or at least similar terms. So I'm going to move that negative 10W to the other side by adding it. And the reason why I put things with the same term on one side is because I can factor out something. I don't have to turn to a binomial times a binomial, but I can understand that we have a W in both of these. So at the very least, I can pull out a W. I can pull out 2 W's because I can pull a 2 out of the 4, I can pull a 2 out of the 10. Leaving me with 4 divided by 2, which is 2. W squared divided by W is W. Plus 10 divided by 2 is 5. W divided by W is 1. And we now have something times something equals 0. That's our whole goal. I want something times something equals 0. Just like before, we're going to break these two things apart. That means either 2W equals 0. If that's the case, W would have to equal 0. Or that 2W plus 5 has to equal 0. Well, I'd move the 5 to the other side using subtraction, which would be 2W equals negative 5. Divide both sides by 2, and we'll have W equals negative 5 over the deuce. Now, could we do the method from 1 here? Yes. You're going to end up with one of these being 0, so it'd be like y plus 0 times, but it's a bunch of extra work that you don't need to do. If there's 3 terms, we have to do one of the fancy ways. If there's 2 terms, there's always an easier way to do it. 2 terms, always an easier way to do it. Keep it in your head. Don't waste time on a test or a quiz. All right, our last one. I wanted to have one that I might do the air conditioning and Beyonce method on because I do not have a 1 here. So this is a good one to not guess and check your way through, because when you start guessing and checking your way through, all of a sudden you're 5 minutes and you could have done factor by grouping first. So we're going to do some factor by grouping. We're going to make sure that everything's on the same side first of all. So I'm going to subtract P from both sides. I'm going to subtract a 4 from both sides, leaving myself with a 0. That 0 is key, so I can use that zero product property. Now, you might be able to guess and check your way through this. You might put your parentheses and do your stuff. I'm going to say I can't do it, so I'm going to do an air conditioning and Beyonce column. Air conditioning says A times C. In this case, my A is my 5. My C is my -4, so that's going to be -20. Beyonce stands alone. That's that number in front of the P. That's going to be a -1. 20, the first one I always look at is like the middle one. I look at maybe 5 and 4. And I'm picturing 5 and 4 as being a good one because the difference between 5 and 4 is 1. But it needs to be a -20 and it needs to be a -1. 5 or 4, which one should I put the negative on? I'll put it on the 5. Because that would give me -5 plus 4 equals that -1. Now, factor by grouping says split apart your middle term into a -5p and a +4p. Everything else falls down. 5p squared minus 4 equals 0. You'll notice this showed up on the quiz twice. And it was a bit perplexing that people could do this and solve it, but in the next problem, when I gave you this, you couldn't solve it. Would you use factor by grouping if you have 4 terms? If you have 4 terms, that's our whole goal. That's called factor by grouping when you have 4 terms. You group it into 2 terms and 2 terms. That's factor by grouping. If I give you 4 terms, if I give you this and say factor it, you should know how to do that if you know how to do it from here. The whole goal is turn 3 terms into 4 terms, turns 4 terms into multiplication. So I'm going to notice I can pull out a 5 out of both a 5 and a -5. I can also pull a p out of a p squared and a p. You also pull out the smaller of the powers. Leaving behind p minus 1. I could pull a 4 out of 4 and 4. I cannot pull a p out of both of those, so I'm just going to pull out a 4. Leaving behind a p minus 1. And now, as long as both of these are the exact same, I can smoosh together these two. You are combining like terms. Just like if I have 2x plus 4x, it equals 6x. That's because 2 plus 4 equals 6. So we are combining like terms by smooshing together our 5p and our 4, giving us 5p plus 4 times p minus 1 equals 0. I'm going to shortcut this a little bit. If you want to write your equations, awesome. I'm going to note that either p minus 1 equals 0. If that's the case, p would have to equal 1. Or 5p plus 4 equals 0. If that's the case, I would need to subtract a 4 and divide by 5, meaning that p would have to equal a -4 over the old fifth, the old 5. And that'd be it. That'd be our factoring. That's if I have 3 terms. 3 terms means I need to factor it. I need to complete the square, which we'll talk about in a second. And we could put in the quadratic formula. When I get to 4, 5, and 6, we're going to notice that those only have 2 terms. Those only have 2 terms. And I'm going to notice that I don't have a d in both those terms. So we're going to move that 81 to the other side. So we're going to have 16d squared equals 81. Well, to get rid of that 2, I need to take the square root, but we need to isolate it first. So if you're going to take the square root of both sides, make sure your square is isolated. So maybe I should have put that first. I'm like, I can't factor out a d, so we're going to isolate the d squared. It's not isolated yet. I should divide by 16. So I'm going to have d squared equals 81 over 16. 81 doesn't go into 16. But if you kind of are a forward thinker, you know you're going to take the square root of it. And 81 and 16 are perfect squares, so I'm probably going to leave that alone. I'm not going to try to simplify it at all or put it as decimals. Because our next step is to take the square root of both sides, giving me d equals... Now, it equals the square root of 81 over 16. Why would I lose a point? And it's not just that I didn't simplify it. I lost a point right here. I need a plus or minus. Was a square root given to me in the beginning? No. I created it. If you create a square root, you need to put that plus and minus or you will lose a point every single time. So that's plus or minus square root of 81 over 16. Quick reminder how square roots work. If I square root a fraction, I'm actually square rooting the top. And I'm also taking the square root of the bottom at the same time. Well, the square root of 81 is 9. Square root of 16 is 4. So this is just plus or minus 9 over 4. And you're done. The only reason why I did the next one is because we're going to have imaginary numbers. Some of us need practice with imaginary numbers. If you look at your quiz, you'll know. So we're going to notice that to isolate that m squared, I have to divide both sides by that -6. -6, which means I'm going to have m squared equals a -8. Now when I take the square root of both sides, I'm going to have m equals plus or minus the square root of -8. Now, if you remember from imaginary numbers, don't do any simplification until you have the imaginary part out. No multiplications, no divisions, no simplifying. So the very first step is actually to pull that I out, meaning that I want to see this next just to keep things correct. I'm going to turn this into plus or minus I square root of 8. Now we need to realize, we're going to pull out a 2 basically because 8 has a 4 built into it. And a 4 is a perfect square. I think for the easiest way to deal with these is to find a perfect square that goes into it. And in this case, it would be square root of 4. I'd have square root of 4 times square root of 2. Well, square root of 4 is 2. So our answer is going to be plus or minus 2i square root of 2. We got calculators. We should be able to write down some perfect squares to see if they go into them. 8, we should know 4 goes into it. 32, we should know 16 goes into it. Some of those bigger ones, we'll get to one that we're going to have to use our calculator to check what goes into it, but we should be able to check what perfect square goes into it. All right, so that was our imaginary number 1. Now did anyone need that still up? Cool beans. All right, let's isolate that x squared. So the first thing I have to do is I need to subtract 11 from both sides, which gives me a sweet 3 over 2. X squared is going to equal a 48. I'm going to multiply both sides by 2 over 3 is the easiest way to get rid of that because those will just cancel out. Multiply this by 2 over 3. Personally, this is why I always tell you to use your calculators. I would just check what is 2 over 3 times 48.
32.
It equals 32. You could do it by hand too. You can go, you know what? 48, 2 over 3 is really 96 divided by 3, which is 32. I highly suggest you get used to just plugging these big things in your calculator. I know in math, building up to this, like a lot of teachers are like, don't use your calculator, do it all in your head. You're at the stage where you're going to be taking big, complex tests. You want to do this as quickly as possible. Not show someone that you could do stuff in your head and by hand. I want to get the answer quick. So that would be 32. Now when I take the square root of both sides, I'm going to have x equals plus or minus square root of 32. Is there a perfect square that goes into 32? In fact, I know 2 of them. I know 16 and 4 go into it. 16 and 4, I'm going to pick the bigger one, which is 16. So this breaks apart into the square root of 16 and the square root of 2. You can take the square root of 16 to just be 2. So this is going to equal plus or minus, I'm not 2. What's the square root of 4? Yeah, it should be probably a 4. I said it. 4 square root of 2. You guys misheard me. You thought I said 2. Yeah, guys. And obviously this was a 4 the whole time, not a 2. I just put a line on it. It's like when you turn an F into an A. All right. Do we have questions on solving by square roots? Real quick, does anyone know what time class ends? Because I'm all 55. Okay. 60? At 60? 1160? All right. Let's talk about solving by completing the square. I do have every step laid out here. Here's the big one I'm going to keep track of. you need to divide both sides by a so that you just have a 1 in front of your square. This is the one that most people forget about. I'm going to box it, I'm going to star it, and we're going to do one example of it. But you can read through all that one. I think it's more productive if we do it all together and you understand what's happening there. My job when I complete the square is I actually want something squared equaling a number. So I can take the square root of both sides. It's not going to be x squared. It's going to be like x minus 2 squared. And then we can take the square root of both sides. I can still isolate something. That's my goal. And that's why it's called completing the square. I want something squared. So if we look at this example here I have x minus 3 over 2 squared equals, and it allows me to take the square root of both sides. That's my goal right here. Notice our name is really just this one step, completing the square. So your first thing is to make sure that your first number is a 1. Yes, I'm good. I can move forward.
Can we just factor this though? This is like an easy factoring one.
It could be. It is. This one is not. But be aware that on the test or quiz, I could tell you have to factor one. You have to complete the square, and you have to so pay attention to all these steps. In fact, a lot of times completing the square is easier than factoring, especially ones that aren't factorable. But let's go through this one. Completing the square starts with you actually rewriting this with the 20 on the other side. And I'm going to add one caveat to that. When I rewrite this, I'm going to put a plus something. I'm going to leave a blank here purposefully. And that's going to equal a negative 20 plus something. To complete the square, you're basically factoring something. You're making something that's factorable, but factorable so it's just like x minus 2 times x minus 2. That's how it's completing the square, that you're creating the same thing twice. Now, the good news is it's really easy to do. What you're going to do is you're going to take your b term. My b term here is 12. You're going to divide it by 2, and you are going to square it. So it's going to look like this. We're going to, in this thing, take that 12. That's the only thing that changes. Everything else is fixed. Divided by 2, squared. Divided by 2 squared is permanent. The only thing that changes in this is you need to take that b term and put it on the top. Otherwise, it's divide by 2 and square it. Yeah?
Would you not just make it 6 squared?
I would not for this example. You can. You can. I just like to have it all written out for your notes, depending how strong you are at knowing this stuff. And then I'll go to the other side, and I'll write the exact same thing, 12 over 2 squared. But you could just write it as 6 squared if that helps you. I like seeing it all laid out. All right. Yeah.
Are we going to get answers in the example where it doesn't, it comes out as a decimal?
We will not have decimals. These will all be simplifiable. You can simplify the radicals. So none of this should be you plugging in your calculator.
All right.
Which is why I like completing the square, because when we get to the quadratic formula, it takes a lot of simplifying. This doesn't take much simplifying because it keeps everything as simplified as possible. You'll see as we go through this. All right, now, we already know that 12 divided by 2 is 6. So what you're going to do in your next step is, honestly, you need something squared. That something squared is grab this, that y, grab what's in the parenthesis, which we know is 6, and it's a positive 6. Notice I didn't put 36 here because this squared takes the place of both of those squares. That 12y is still there. If you did y plus 6 times y plus 6, you would get out y squared plus 12y plus 12 over 2 squared. That's just what you get. That's what we created.
Where does the 12 over 2 come from again?
That is the formula that you have to use.
Oh.
It creates that perfect square. So it creates a situation where if I do y plus 12 over 2 squared, it would equal all three of these terms. So your job is to memorize that b over 2 squared. Yes?
Oh,
Okay.
Always over 2?
Always b over 2 squared. So that's why I only have the 12 colored.
I was like,
Everything
those
else
are
is
random
fixed.
numbers.
Yeah, it's always this b term that goes on there. It won't always be 12 over 2, but it'll always be something over 2. All right, our other side, we'd have negative 20 plus 12 over 2 squared. Well, 12 over 2 squared is going to be 36 because it'd be 6 squared, which would be 36. So we're going to have 16. Negative 20 plus 36 is 16. Now we could take the square of both sides. We could take the square root of both sides, giving me y plus 6 equals plus or minus the square root of 16. Now we're going to subtract 6 from both sides because I do have a y plus 6. I do want to isolate that y. I will have y equals negative 6 plus or minus. The square root of 16 is 4. Yeah.
Where did the square go on the y plus 6?
I took the square root of both sides. So sometimes I don't write it because it gets a little cluttered, especially when you're with colors, it helps. But sometimes when you have pencils, like you lose track of what just happened. So sometimes I'll just show that what happened. Because sometimes there's just too much stuff happening in one step. So I just show the after effects. So when I take the square root of both sides, the square root and the square cancel out, and I just have y plus 6 equals plus. Now, we should simplify this. This is really two equations. This is y equals negative 6 plus 4. It is also y equals negative 6 minus 4. Well, negative 6 plus 4 is y equals a negative 2. That's one answer. And for the other one, y equals a negative 10. Now, I forgot who brought up the fact that it's factorable. You know it's factorable because these don't come out to any weird numbers. They're whole numbers, so it would have been factorable to begin with. Our next one's going to be a little more complicated.
We just moved the 44 to the right side?
Yep, let's do that. But let's work slowly. So we have 4a squared minus 20a. Move the 44 to the other side by subtracting, which equals a negative 49. Now, what did I have you circle or star above?
Y squared.
Divide by 4 so it becomes
You have to divide both sides by a. That's why I told you to do this. This has to be a 1. This right here has to be a 1. So your first step, or after you move stuff, is to divide everything by 4, because that needs to be a 1. That is now going to give me a squared minus 20 divided by 4 is 5a. I'm going to leave a plus a blank equals negative 49 over 4. Oof, almost forgot over 4. Negative 49 divided by 4 plus a blank. Now, just a reminder, what goes in that blank is something over 2 squared. So both of these you can already have partially filled in. It is always something over 2 squared, something over 2 squared. What is that something? I'm going to put the negative 5. It doesn't ultimately matter if you remember it's negative or positive, but I'm going to steal the entire negative 5 just to help remind myself of something. So I'll put a negative 5 there, a negative 5 there. Now the reason why I'm pulling out the whole negative 5 is because I'm going to pull down the a and the negative 5 over 2. So I'm going to actually have a negative in here. I'm going to have a minus versus the y plus 6 from the other one. I need to create that negative. When I do this multiplication, I should be able to get a squared minus 5a plus negative 5 over 2 squared. The only way to do that is to have a negative between them. Now I'm going to quickly just go, you know what? Negative 5 over 2 is a positive. Well, negative 5 times negative 5 is a positive 25. Over 2 times 2 is 4. So I really have negative 49 plus 25, which is going to go ahead and equal 24, or negative 24 over 4. What's negative 24 over 4 equal? Equals negative 6. Thank you.
How did you get rid of the negative 5a from the left side?
From the left side?
Yeah.
Remember, it's buried in here. If you take a minus 5 over 2 times a minus 5 over 2, when you do your distributing, you'll get that negative 5a back out. It's built into this.
When you pull in the parentheses,
I don't know which one you asked that question. Does that make sense? It's baked in here. That's why we picked this number. So I can write it as just a binomial times a binomial.
Will it always be like that?
It will always be like that because you created this. You're basically factoring it into a minus 5 over 2 times a minus 5 over 2. So you are doing the exact same thing as these, except I picked a number to make the factoring easier. I made it perfectly, like, let's say if I factored this and it turned into 5p plus 4 times 5p plus 4, I'd turn it into 5p plus 4 squared. It only works if it's a special case, and we are creating that special case. We are creating that special case where I can turn this into a factorization of a minus 5 over 2 times a minus 5 over 2.
So it's just whenever A and C are both squared.
Yep. Okay, so now we can take the square root of both sides, which is going to give me a minus 5 over 2 equals plus or minus a square root of negative 6. We should realize with the negative 6, I should pull an I. I'm also going to move the 5 over 2 to the other side to be just a equals 5 over 2 plus or minus I square root of 6. There's really just one rule you need to know for this. B over 2 squared and how to create this. Otherwise, completing the square is one of the easiest processes out there, as long as you don't have weird fractions you have to deal with. But for these, it generally sits up well because it's already simplified for you. You'll notice when we do the solving by the quadratic formula, we're going to have to do a lot of simplification, where this will already give you the simplified version for you. You don't have to worry about much. This is why I typically gear towards doing the completing square. I know a lot of people don't take the time to learn it, but it is one of the easiest methods if it's not easily factorable. And there's a 1 out front, or it's easily divisible. Yeah. Say that one more time.
Like, do you want us to simplify the root answer?
You can't simplify root 6. There's no perfect square that goes into it.
You can't do root 2 times root 3?
You could do root 2 times root 3, but there's no way to simplify either one of those. So you could rewrite this as I times square root of 3 times square root of 2. But neither of those are perfect squares, so you turn that back into I square root of 6. You just went in a circle.
It's like simplifying 5.
Yes, it's the exact same thing as simplifying 5 to 2 plus 3 or something. Yeah.
Okay, so on the test, will we get to choose, or is there certain problems that you have to?
Definitely on the quiz, I will say you have to factor this one. You have to complete the square on this one, and you have to use the quadratic formula on it. Because I'm going to pick ones that work for each situation. I'll pick one that's factorable, one that generally I would use this for.
But isn't that easily factored?
Yes, but maybe this one. And maybe not this one. Maybe it could be something that doesn't have a fraction in it, but it's not factorable. There's an infinite number of things out there that aren't factorable but are easily to complete the square.
What's the situation that makes, like, the beginning a minus 5 over 2, or, a minus 5 over 2 squared? Like, I'm trying to make sure I get this.
We'll go back to it if we have time, because this is not the time, I just want to fly through these algebra 2 concepts. If we need more in-depth, we can do that later. All right, the last thing I want to get to is solving by the quadratic formula. It is our bazooka. It is the one that will always work, but it's not always the easiest to do, because you're plugging everything into this big, hard equation, and you got to do a whole bunch of simplification. I will note that this is just completing the square. This is completing the square on steroids where everything is done for you. We're taking square roots of a perfect square. It's actually, everything is baked into here. All right, in order to use the solve by the quadratic formula, A, you have to know the quadratic formula. And B, you have to realize that everything must be on the same side. So I have to have 6x squared minus 3x plus 9 equals 0. Noting that my A is 6, my B is negative 3, my C is a positive 9. The quadratic formula says we're going to go x equals, and we'll do our negative b. Well, our b is already negative, so it becomes a positive 3 plus or minus the square root of b squared, which would be negative 3 squared, minus 4ac. So that'll be 4 times 6 times 9. All over 2a, well, that'll be 2 times 6. Now, you're big boys with calculators. I strongly suggest you get in the habit, especially if you have a TI-84, which you're supposed to have, just plug everything that's under the square root into your calculator. Type in negative 3 squared or even just 3 squared. Be careful to use parentheses with negatives because we know it should be 9. But I would just type in parentheses, negative 3 squared minus 4 times 6 times 9, and see what I get out. And what do we get out? Negative 207. So we have 3 plus or minus the square root of 207 all over 12. And it should be a negative 207, which we know is going to have an I in it. So I guess we can keep going. We can go, that's 3 plus or minus I square root of 207. 207 looks really big, odd, probably simplifiable. Is there a perfect square that goes into 207? You don't have to just mentally look at it. Just go in your calculator and do 207 divided by 4. 207 divided by 9. 207 divided by 16. If you get to 16, you went too far. What goes into 207? 9. How many times? It's not that hard if you just are willing to plug it in a calculator. So let's just keep going. So this is going to be 3 plus or minus I times square root of 9 times square root of 23 all over 12. Now, Jagger, the reason why we could break this apart and why I want to is because we know the square root of 9. Square root of 9 is 3. That's the only time we break it apart is if there's a perfect square that goes into it. If that helps with the why we didn't break apart the other one. All right, so that's going to be 3 plus or minus 3I square root of 23 all over 12. Is there a number that goes in all 3 of those terms?
3.
That goes into 3, 3, and 12.
Oh, yeah.
3 goes into all those. If I divide everything by 3, I will get out 1 plus or minus 1I square root of 23 all over 4. Oh, yeah, that's it. That's our answer. So the nice thing about completing the square, if you would have completed the square on this one, you would have jumped straight to 1 over 4 plus or minus I squared of 23 over 4. Like, it would have just worked out to a more simplistic way. You wouldn't have had to simplify everything. Because completing the square automatically keeps things simple as it goes. Yeah?
So would you have to write it as 1 plus I plus 1
Nope, this is done.
Okay.
The only time I want you to do the addition and subtraction is if it comes out to, like, this one. You can do both of those and get the answer. Questions on any of that?